Alright, learning target 2.2. I can compare the mean and the median from different data sets. Find the mean and median, and then state which has the highest mean and median. So we're just focusing on the mean and on the median. So on these dot plots, we really don't need the calculator, okay? So the median is generally the easiest one, and then the mean we're going to need to use a calculator for, I guess, not to graph it, but just to look at it. Okay, and I will show you how in the calculator, using one of these sets of data, how you can do it on that as well. Okay, so to find the median, okay, we can just realize that, you know, those two 12s, so I'm just going to add them up. So two 12s added together, 3 13s, 5 14s, 4 15s, 2 16s, and a 17. So we should have got a total of 242, which we're going to divide by a number, right? Now, if I count these, we've got 5, 10, 14, 17. So divide by 17, and we get about 14.235. Let's round to the nearest hundredth, so 14.24. Okay. Oh, and that was not the median, that was the mean, wasn't it? So 14.24. Then to find the median, we just cross out a low, cross out a high. Just kind of work my way through it. We end up with 14 being our median. Okay? So then for the second one, same idea. Okay? Now I'll just kind of mention right here, we've got an outlier here, most likely. It's kind of removed so that it won't affect your median as much as it will your mean, because it's going to pull your mean up to be higher. So I'm just going to tell you right now, I'm guessing that our mean is going to be higher on number 2, and possibly our median as well. But for sure our mean is going to be higher on data set 2 than on data set 1. Okay? So let's check it out. So we've got 3 12s. So we add those up. 12 plus 12 plus 12. Plus 2 13s, plus a 14, plus a 15, and a second 15, 3 16s, 4 17s, and a 21. And we get 243. Is that right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have one less number here, so we divide by 16. And that gives us 15.1875. So rounded to the nearest hundredth, 15.19. Okay. Then the median, so cross one out. 2, 2. So it's going to be in between 15 and 16, so 15.5. So both of these are the higher ones, okay? And our mean of 15.19 and a median of 15.5, okay? Interesting, because there was a lot more numbers right here, that mean actually wasn't bigger than the median, okay? Whereas the mean here was bigger than the median because a few extra higher numbers than lower numbers. Okay, so that's all there is to it. So let's move on to the next. Okay. Alright, so length of book titles. So again, we're looking for the mean and the median between both. The median is the easier one to find, right? So we just cross them out. But this one would be pretty easy to find the mean too, right? Because 3 1s would give us 3. 7 2s, 14. 2, 3, 6, 4, 4, 16, and 1, 6. So I'd have 12 right there, 15 when you add that. Those would make 30, and 15 would give us 45. 45 divided by however many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, so we go 45 divided by 17 gives us 2.647, 0.5882, so a big long number, but we're going to round to 2.65 when we round to the nearest hundredth. Okay, then let's find the mean of the other one. So that would be 3 again. This would be 16, 12, 1, 4, and 1, 5. So we have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So again, 17 we're dividing by. Add these up. Okay, 5 and 3 is 8, and 12 is 20. Another 20, so 40. So 40 divided by 17 gives us a mean of 2.3529, so round to 2.35. Okay. Then to find the median, right? 2 from the top, 2 from the bottom, 1 and 1, 1, 2, 3, 1, 2, 3, here, 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 here. So easy to see, median of 2. Number 3, top to the bottom. And we get 2 as well, don't we? Okay, because there's so many 2's in this data set, that's kind of one of the reasons, and it's kind of in the middle. Okay, so they have the same median in this case, but we have a higher mean on data set 1. Okay, the number of 4's they have and the 6 up here are probably the reason why that pulled that data up higher than the other one. Okay, all right. Now data set test scores. Okay, so we add these ones up. So again, we want the mean and the median for both. The mean and the median. Okay, so I've got 138, a 39, and a 40, a 44, and 2 45s. Trying to count as I go. A 47, a 48, 2 49s, a 50, and a 51. So we're at 12 numbers so far. Then 2 53s, 2 56s, and 1 57, and 17 total. So we go 820 divided by 17, and we get 48.2352941. So we round up because we're at 3. So 48.24. Okay. Then we can do the mean for the other one again. So we start out at a 37. And then 2 39s and a 42, 46, 2 48s, a 50, 51, 2 52s, and 2 53s. So 8, 9, 10, 11, 12, and 13. And then 58 and 59, so plus 58 plus 59. So we get 697 there, but we only have 15 pieces of data, so we divide by 15, giving us 46.46 repeated, so we round that to 46.47. So pretty easy to see which one has the higher mean. Okay. Interestingly enough, it's data set 1. I almost guessed data set 2. But based off the numbers we have, that's how many we got. And I think I made a mistake there. That number seemed a little too low. So I actually redid it and I got 727, so I must have missed a piece. Divide that by 15 and we get 48.4666 repeated. So 48.47. Okay, so this one, data set 2, was actually bigger on the mean, which is kind of what I suspected, because it seemed like they have a lot more data that was up in that higher area. Okay, so median now. So 1, 2, 3 on the top, 3 on the bottom, 3 on the bottom, 3 on the top, bottom and top, and we get 49 for our median. Then 2 on the top, 2 on the bottom, 2 on the bottom, 2 on the top, 2 on the top, 2 on the bottom, 1 and 1, and we get 50. So median and mean were both higher on data set 2. Okay. All right, now let's take a look at number 7 and 8, and let's actually use the calculator for this one. Okay. So on the calculator, we're looking at that educational attainment by U.S. state, comparing the mean and mean of data set 1 and 2. So we go over here to new document. Okay. If we have one that's unsaved, we always hit no. So I'm going to pick data and statistics. Okay. Then we're going to go over here and press Control Doc so we can get lists and spreadsheets, and I've got to name them. So let's go set 1 and set 2. Okay. Make sure we never put anything in these two boxes, right? And then we're just going to go down here and we're going to put our data in. Okay. So I'm going to go through it pretty quick. So 21, 24, 25, 26, 27. I don't have to put them in order. And I don't even have to count them because we can get the calculator to do everything for us. Okay, so there's data set 1. I go back up to the top and I do data set 2. There's 3 25s, 2 26s, 2 27s, 2 29s, a 30, 31, 33, and a 36. So there's actually 16 pieces of data here, whereas the other one only has 15. Now, see how I've left that in there like that? If we do that, it's not going to work. So make sure you hit enter, and then we can go back up to the top if we want to. Okay. So now what we're going to do is we are going to hit menu, and really quick, I'm just looking right now at the data to make sure we got the right number. Okay. So we go menu, statistics, stat calculations, one variable statistics. Now the number of lists we're doing is 2, so I'm going to choose 2. Then I hit OK. So I tell it what my first list is going to be. I want that to be set 1. My second list, set 2. Results column C. There's nothing in column C, so yeah, we can do that. And then we see our information. Okay. Again, now we can see that we've got some pieces of data here. So remember that the X bar here represents our mean. Okay. So in set 1, a mean of 29.2, which if we look at that, sometimes it'll abbreviate the decimal and it'll have more here. For set 2, we have that mean of 27.375. So basically 27.38 is what we'll say. Okay, now these guys we don't really care about, so we scroll, keep going down, and we can see that 5-number summary: minimum, first quartile, median, third quartile, maximum. We only care about the median here, so our median here. So we've got for set 1 at 30, for set 2 at 26.5. Okay. Now, can I take this and I could also click down here to add variable, and I could find their dot plot. okay, which is the same one we see, kind of cool. But I can hit menu, plot type, do a histogram. But if we want the median, it's the box plot that's going to help us with that one. Okay, but it doesn't give us the mean. You have to do this part if you want the mean. But I can also, here's a cool thing, when I get to comparing, I can hit menu, plot properties, add X variable, add set to, and then I can compare the two and see how different the data is. Look at those different medians. Okay, one is much higher than the other because of the way the data set is. Okay, like if we go back to see that dot plot that you guys are looking at, okay, we can see more data up here, more data down there. Okay, which is why set 1 is higher on both of those. So we can take a look at that now and move on. Okay, so we talked about that, and again we found that for data set 1 it was 29.2 and the median was 30. For data set 2, I believe it was 30. That's what I wrote down, so I guess we'll see. Yeah, I was correct. And then the mean of 27.38 and the median of 26.5. So data set 1 has both of them higher in this case. All right, now we're going to create a histogram and then find the mean and median and state which has the highest mean and which one has the highest median. Okay, again we're going to take a look at this one, number 9 and 10 on the calculator. And then we are going to, we'll do 11 and 12 on the paper and kind of see how to do. Okay, now going back to our calculator, we still have this data up here, don't we? Okay, so we can get rid of it by going all the way up and hitting delete. Okay, and I could just move this across, delete everything because I don't need it anymore. Now here's the problem though. If I want to rename this set 1 and 2, I press set 1, all my data is still there. Okay, now can I just overwrite this data? Yeah, I could do that. However, sometimes I don't really want to do that. So if I go to the home screen and start a new document, okay, undo lists and spreadsheets, now when I put in set 1, it will have erased it, and so we can kind of start from here. But that's good to know if sometimes you accidentally mess it up, then that's a way that you can help out with that. All right, so then we enter in all our data here. This is for data set 1. Okay. So we got 15 pieces again. So now data set 2. This is the tedious part, right? Okay, so both have the same amount of data. So then we go menu, statistics, stat calculations, one variable. I'm doing 2 lists again. Okay, tell it which list I do. Now, each one could be the other one, but I like to keep it in order because I just think it's easier that way. Okay, and if I want to double check, I can see right down here set 1 as opposed to set 2. So again, we can see the means. Okay. We can see that set 1 has a higher mean of 7.55. Set 2 is 6.62 if we round. Okay, right. Okay, then we're gonna go down here to the medians, and we've got 7.25 for set 1 and 6.5. Okay, so again, set 1 has both the same. They're both higher. Okay. But we also wanted to see those histograms. So let's kind of look at those histograms and see how that compares. So control doc, data and statistics, click to add my variable. Okay, now we wanted a histogram, so I go menu, plot type, histogram. And I can just toggle between set 1 and set 2 if I really want to. However, because it looks like the bottom here is different, we actually want to compare them side by side. So I go menu, plot properties, add X variable, and I can add set 2, and now see how different that looks. Okay, and so I know set 1 has a higher median and a higher mean, which I can see because my data's here. It's a fairly normal data, unimodal. This one's kind of more of that bimodal shape to it. But definitely median and mean are higher up here, and they're going to be lower down here. Okay, so then we just take these, put those down on the graphs, and we would be able to talk about how set 1 has both of them higher than set 2. Do both of them. All right, so we're good there. So now let's take a look at doing this by hand. And to do this by hand, we do what we call frequency tables, okay? Because we want to take a look at how many are within each zone, okay? That's the main point here. All right, so we've got, I don't want to do too few, but neither too many. So 33 is our lowest, so we're probably going to go 30 to 34, like every 5. 35 to 39. 40 to 44. 45 to 49. 50 to 54. And then 55 to 59. Okay? Then we do the frequency, how many we have. So I see 1 here, 2 in the next category, 1, 3, 9, and 1. Now, in this histogram, we want to keep, in data set 2, we want to keep the same ones because we're trying to compare them, right? So there's 0 in 30 to 34, as well as 35 to 39, there's 0. Now we go to 40 to 44, and we have 1, 2, 3, 4, 5, 6. Then 45 to 49, 1, 2, 3, 4, 5. Then 50 to 54, 1, 2, 3, 4, 5 again. And then in the last category, 55 to 59, we have 1. Okay, so that kind of tells us what our intervals are going to be. Okay, so basically I think of this line as being 30, okay? So then I'm going to go every 5, so 35, 40, 45, 50, 55, 60, okay? So 35, 40, 45, 50, 55, and 60. And then our highest is 9. So that's, how high we want to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, now we start putting them in. And notice we go from 30 to 34, so kind of like we're starting on this bar, and I go up to 1, and then I'm going to go right there, okay? And then on my next group, there's 2 of them, so I'm going to go up to 2, and then over, okay? Then the next one, there's 1, so I go up to 1, over. And the reason I'm because the way it doesn't include 35 here, that's why I'm kind of trying not to end the bar graph at that number, okay? So then 45 to 49, there's 3. So it'll look kind of like that. Then from 50 to that, we go clear up to 9. And then we've got 1, our last category. Okay, so it'll look something like that for our histogram. Okay, then the next one, we go 0, 0, so we start at 40, and that gives us to 6. Okay, so at 40 we go up to 6 and over. At 45 we go up to 5, over, then let's draw that down like that, and up to 5 again, and over. So let's color that in. And the last one only has 1, doesn't it? Again, only one. Okay. So, now looking at these, finding the mean and the median, okay, that's where it's helpful to use a calculator, isn't it? Because that finds it for us. But my guess here, looking at things, okay, we've got a unimodal. This one's more uniform, so it's going to be more in the middle. So it's probably going to be pretty close to 50 on both of them. Probably because this is a lot smaller than this one, actually it's probably going to pull it more to this side a little bit. So maybe around like 46 or something. Whereas data set 1, we've got a whole lot right here, and then like very little to the right and very small pieces to the left. So it's probably going to be pretty close to 50 would be my guess for the median and the mean. Okay, so let's find the mean for both of them first. So if I go 33 plus 36 plus 39 plus 41 and so on. Okay, you probably don't want to hear me recite every single number that you have in front of you. Though I hope I don't make a mistake. That's what's also nice about the calculator. So 820 divided by 17, I believe. 6, 7, 4, 5, 6, 7. Yep. So 14, 15, 16, 17. By the way, I just found the median too. So 820 divided by 17 is 48.24. Okay, so I was pretty close, right? Kind of split the difference. Now let's take a look at the other one's test scores. So 40 plus 40 plus 41 and so on. So basically that shape can kind of give you a general idea of where things should be. So 704 in total. And again, 1, 2, 3, 4, 5, 6. Oops, I left off 2 numbers, didn't I? So that is actually incorrect. I need to add 47 plus 51. So it's 802. So there's 7, right? 1, 2, 7, so 8, 9, 10, 11, 12, 13, 14, 15, 16. There's our median. And our mean, we have 17, so 802 divided by 17 gives us about 47.18. Okay, which I was actually fairly close, but a little on the low end, wasn't I? It was a little more over here. Okay, but data set 1 has both higher. And a lot of times you'll see that they have both higher, though there are some situations where you can have one higher than the other, and they kind of flip-flop. And that really depends on an outlier, is really when that happens, you've got an outlier somewhere. Okay. All right. So we are good there. So let's take a look now at these ones. And looking at these two, I would honestly prefer to do the minutes to run 5K on the calculator. So why don't we do that one on the calculator? Okay. So to graph these, okay, first we need a number line. So 5, 6, 7, 8, 9, 10. There's a lot of 0.5, so we should probably include the 0.5s as well, huh? All right. Okay, so we want the mean and the median, right? Remember, in order to get the box and whisker, we do have to have the median, don't we? Because we do the low, 5.5, and we do the high, and we do the median, so there's our median, so 8.5. Okay, then we do the, so that's our cuts out, and we go the opposite direction between 7 and 7, right? So it would be 7. Then going the opposite way, in between 9.5 and 10, so it'd be 9.75. First and third connect with the median in the middle, then we add on those whiskers. Okay. Now, should we really take a look at outliers? Probably. But in this case, we're not going to worry about that. Okay. Because we don't really want to, just for what we're doing, I'm not too concerned about the outliers. Okay. Now, to find the mean, we still have to add them all up and do that. So 5.5 plus 6, and so on. You get 142 divided by, I believe there are 17. Yep. We get the mean of 88.35. Okay. Now we do the same thing for data set 2. Okay, but let's do the mean first before I start crossing things out. So I'm adding everything up, dividing by the number. My goodness, there were so many 8s, I want to make sure I got them all right. 7 8s. Had to redo my numbers because I got worried there. So 121 divided by, now it looks like there's only 15 in this case, right? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Yep, there's our median, by the way. So 15. So we get 8.01, or not 107. Okay. Then we go for our first quartile. Oh, so lowest was 6 here. Highest was 10. Okay, median of 8. First quartile is also 8. So that just stays right there. Third quartile hopefully isn't 8. No, it's 8.5. So that guy is kind of a weird looking guy. Okay, I'm sure there's some outliers there, which would adjust things slightly. Okay, but again, we've got the lower median here on data set 2, and we end up with less of a, probably because there's no, those are the same thing, those numbers are pretty low. So data set 1, it's got both higher. All right, now this one again we're going to do in the calculator, so we'll be able to compare the graph, the mean and the median in the calculator, so we probably won't come back to this page, and we'll go from there. Do problems now with the calculator. Okay, now I've done us a favor and already entered the data in, so we don't have to sit and watch me do that. So interestingly, if I go back to the home screen and I already have something on a document, if I go to number 4, current, it'll take me back to where I need to be. Okay, so there's data set 1, data set 2, okay, for the minutes to run 5K. So I go menu, statistics, stat calculations, 1 variable, choose from a list of 2, because we have 2 lists, and I choose set 1 and set 2. Sometimes you may have extra ones here, and there's a reason I did that, and I'll explain that later. And then column D, that would work, so I hit OK. And then we see there's data set 1, there's data set 2. So there's our means, okay? So data set 1 has a lower mean than data set 2. They're pretty close, but a lower mean. Then medians, data set 1 has a higher median than data set 2. They're pretty close together again, but let's see if I can pull this up and look at them together. Yes. Oops. Did not like that, did it? Okay, so escape out of that one. so it's not really, I wish they kind of put them closer together. Maybe this is what I can do. Maybe if I just go down here, put it in. No, it does not like that at all, does it? Alright, so much for that idea. So, again, data set 1 is larger on the median, but smaller on the mean. Okay, that's interesting enough. So kind of that flip-flop there. Let's see why. So we go Control Doc, Data and Statistics, click to add a variable. Okay, we want the box plot, so plot type, box plot. But I don't like toggling between the two, right? That's no fun. So let's actually, again, if we go Menu, Plot Properties, Add X Variable, Add Set 2, and I can compare that one now. Okay, and the reason, so the median here, higher, lower, but this represents a quarter of the data, so half of the data over here, okay, which is we've got some higher numbers here, and so we're able to, it's going to pull that mean up, so that ends up being higher than the mean on data set 1. Okay, so that's what it looks like. Now, I was really curious of what it would look like when we did the other ones. So for that reason, I actually, whoops, didn't want to do that. Plot properties, remove Y variable. Okay, so if I go to set 13, that was question 13. Okay, do a dot plot or box plot. Okay, and then we add set 14 was that weird looking one. Okay, oh wow, see, it actually doesn't have any whiskers because those are outliers. So that's a completely weird looking plot, isn't it? So let's add 13 here. I think there's a way you can change the colors here. I'm not sure how you do that. Because sometimes it pops up with one color or not. But look at that. So completely different looking types of graphs because the data here on data set for question 14 was so close together. You've got these outliers out here. And it's a really weird looking graph, isn't it? Okay, but I just wanted to show that to you guys as well. And we can see that it's time to go. So we are going to end this and we're going to call that good with that.